Hi, and welcome to the breadboard. So what are we going to do today? Well, we're going to take this and we're going to test it on Windows 10 for IoT. And what is this? This is the 7-inch official Raspberry Pi LCD screen. Now, if you haven't already done so, I would advise you to watch my previous videos, which is assembling the 7-inch LCD display ready for use with the Pi, including mounting the Pi onto the back of it, and I'll link that in here. And also testing it with Raspbian. Now, you don't have to test it with Raspbian, but in order for a level of confidence, if you want to do that, that's fine. But I assure you that it's not essential. And the main thing is that you have followed the instructions to assemble the Raspberry Pi and the LCD display correctly. So if you haven't watched that video already, go and do it. Now, the next thing is that you have a Windows 10 SD card prepared, and the video is here to show you how to do that. Once those two things are done, then we will continue with this video. And what I'm going to do is I'm going to start with a brand new created Samsung 32GB Pro SD card. That just makes the boot up process a little quicker. Aside from that, it doesn't really matter which one you use as long as it's one that does work with the Raspberry Pi. So a Samsung Pro, a Samsung Evo, a SanDisk 16 gig Ultra or 32 gig Ultra would be ideal. There are others, and just check with the hardware compatibility for what they are if you don't have one of the ones I just described. I am using the Samsung 32 gig Pro just because it's the fastest one I have, and it means it will be easier for you guys. As I said, if you haven't watched those videos, go and do it now. And once you are ready with the SD card and the display assembled correctly, then we will continue. And for me, that's an instant. For you, that might be a case of pausing, going watching those and coming back. Let us continue. I'm going to now switch to my other camera so that I can be recording directly on the 7-inch LCD display so that you can see what happens from the point that I boot up. I'm going to do this with the Wi-Fi adapter connected, not an Ethernet adapter with a cable, and I'm going to use my 2.5 gigahertz mouse adapter, which is a wireless Logitech mouse, and my wireless Logitech keyboard. Now, I'm not sure if the Logitech keyboard will work. I may have to switch to my Apple keyboard. I know that the drivers for the keyboards are a little more limited, but we'll see how that goes. I haven't tried this keyboard with the latest Microsoft build for the Raspberry Pi Windows 10 IoT, but it will become evident real soon. So let's stop this and flip to the other camera and see how we go. Okay, forgive if the white balance is a little bit off, but I think it's good enough to be seeing with on here. So what we have, I'm looking at the back of the assembled Raspberry Pi mounted onto the 7-inch LCD official display. You have the touchscreen controller right here. The remainder of the control system is built onto this board here. Power will connect to this connector. This one will not be connected to the power. Here's the ribbon cable for connecting the LCD to the Pi. And what we have down here is we have the Samsung Pro 32GB. I've just finished flashing it with a brand new image from the Microsoft website. I have not powered this up yet. It's the same image we were using on the previous videos. I just reinitialized it to be net new. We have the mouse wireless adapter, the keyboard wireless adapter, and we have the official Raspberry Pi Wi-Fi dongle, which is supported by Windows 10, as we've already shown in previous videos for running the Wi-Fi on Windows 10 with an HDMI display. So I'm just going to plug all of these into the Pi, and then we will continue with the power-up process, and I can show you how this all works. So I'm just going to turn this around, and I'll plug these into the same sockets as I had them before. If you do get any issues with the Raspberry Pi not recognizing the Wi-Fi adapter or the Wi-Fi adapter not working properly, you might want to try rearranging or moving the Wi-Fi adapter a little bit away from the other adapters, because they're all working on the 2.5 gigahertz band, and it is potentially plausible that they could interfere with each other. So just as a word of caution, mine seems to be working just fine, but I have had experience before where there was some interference. So depending on your situation, things might change. Okay, what I have here is a dedicated 5 volt 2 amp USB power supply. You can see here it's got a just a 2-pair wire. It's not the standard USB cable. There's no data in this, and it's just for supplying power to the Raspberry Pi. It's 5 volts at 2 amps. So just going to plug this in a moment. I'm just going to adjust the camera for, as I said, a better view. Okay, I think that's managed to remove most of the reflections. So now I've done nothing else except put the SD card in and plugged it in. All the construction is exactly as was shown in the previous video. So I'm just going to power this up now. Just got to make sure I get the adapter the right way round and plug it in. Now, okay, so there we go. Powering up, as you can see, it's already immediately putting things onto the display. So this is doing the same boot up, so it's going to take maybe 90 seconds or so with this particular SD card in, and as you can see, it's actually working on the LCD already. The power connections are at the top of the Pi up here, not the bottom, and you can see that the display orientation is correct for the way the camera is right now. So I'm not going to pause the video. I may make the boot up process a little faster, but I just want to show you this powering up. So this is doing all the standard things that the HDMI output did, with a couple of exceptions. For instance, right here, the welcome to the Windows 10 IoT core and the please wait while blah blah is happening was overwriting each other. So that's a little bit annoying that they're not handling the different screen resolution properly. And as you can see here, it is working as well quite happily, but you can see that there's a couple of things on this initialization screen that's not taking care of the screen resolution. So we're just going to wait a little bit and see if it fixes itself. My keyboard also does not appear to be responding. The mouse is working quite fine, but the keyboard, which is one of these Logitech wireless keyboards, is it's not responding to allow me to move up and down on the screen, so I can't press the enter key. So I'm going to change that. With this screen that you're currently looking at on the 7-inch display, it will automatically go in and default to what you want anyway. So ironically, it's an Apple keyboard that I'm going to use for this one here. Just going to plug that in instead of the other one. Oh, sorry, I blocked that right as it flipped to the main screen. As I said, it will time out with a configuration for a US keyboard and country code and everything. So I'm just going to plug in this other keyboard now. But you can see here that from a display perspective, it is working just fine. Okay, so that keyboard's now plugged in. That's the white cable leading to it. It's just plugged it in additionally to the USB. So that's the display, and as you can imagine, the mouse still works quite fine, and it will actually scroll for what we picked. And now now that it's gone past those defaults, I can actually change the basic preferences to the language that I want. So if you had something else, you can still go in and change it. You just couldn't do it on the initial screen because it wasn't working properly. There were no scroll bars here. Now that it's gone through that last part and realized that the resolution is different, the full scroll bar is available to you. And you can go in here with network and Wi-Fi, and it should, in a moment, because I put the Wi-Fi adapter in, show me the Wi-Fis that I have available. Unless I'm getting one of those interference things. So you can see here it's identified the Wi-Fi adapter. It's got the Apple keyboard. For some reason it sees it twice. And right now it's still not seeing the network. Okay, so one of the things I mentioned a moment ago was about interference. And that's just what I just experienced. I've just rearranged some of the connections, the USB connections on the back of here. Let me just rotate this around so I can show you. I had this Wi-Fi adapter in the bottom port here. I've just moved it to the top one and plugged it back in, and I took out the Apple keyboard again and left these two where they were. I just remembered that even yesterday when I was doing the other video for Windows 10 IoT, it was happily recognizing that I had the Logitech keyboard plugged in, so it should not make any difference just because I've got the LCD display there. So I've just moved this to a different port, maybe because of the orientation of the display or something else, but it's now certainly working with this keyboard. If I just actually bring this keyboard into view here, this one here, sorry about the missing key there, I've got to just going to use the arrow keys, and you'll see that, sorry, tab key, it will let me tab around the display. I'm just pressing the tab, so that's obviously the keyboard is obviously working just fine there. And if I go into the settings, I should be able to go down to the Wi-Fi and hopefully see some Wi-Fi. So there you go. So there was a little bit of interference because of the positions of those plugged into the USB port. So if you do see that, just rearrange them and it should work fine. Now, as before, I'll pick my Oaks Clan network and tell it to connect. It's going to ask me for a key. Okay, so just finished putting in the password. Let's go back and see if it's picked up an IP address and everything else. Okay, there we go. And yes, it has 192.168.1.234. Now, again, with the interference thing, because I've got a wireless keyboard and mouse and I've tucked it right behind the LCD display with a lot of metalwork, I had a little bit of an issue getting a connection. So what I've done is I put it on an extension USB key, and now it's working just perfectly. So as I said before, if you do get a little bit of interference, even though it started detecting the Wi-Fi that was available in my area, it was not allowing me to connect very well. So I've just put it on an extension lead and it's now fixed that issue. Now, as I said, the touchscreen is not working, but I have actually created an application to talk to the touchscreen controller over the I2C bus, that the extra connections on the screen that are there, you get the extra cables for. That's actually for an I2C bus connection. Now, there are some chats going on in the forums that say this I2C bus is shared with the LCD low voltage display bus, which goes through the ribbon cable, and therefore might cause conflicts. Now, I've written a little bit of software to talk to that controller, and so far I haven't had any troubles with it. I haven't got a full app going with it. Just reading the touch values, and I can actually read up to 5 touch values in any one time. So let me see if I can fire that up for you. So I wrote this in Visual Studio, so I'm just starting up Visual Studio. It's all written in C#. It's a very rudimentary application. So hopefully I haven't messed it up or anything. So what I have in here is a standard universal application. And the display adapter, the touch screen on this display adapter is a I2C controller. So this basic layout is a little bit more for talking SPI as well as other things at the top here with the initialization. It's just a generic initialization I use. Everything else in here, though, is to do with the touchscreen. The touchscreen is an FT5206. Controller. It's basically a microcontroller in its own right, and you don't actually have to initialize it as a touch controller. You talk to it as an I2C device, and it will simply return you up to 10 touch points when it's running. And I've got just a red button dot and a button to click, so we can just test a couple of things here. It doesn't do a huge amount. It just puts the touch segments on here. So if I now run this, okay, that's now initialized and deployed, and if you look at the screen from my camera, you can see that it has appeared on the screen here. Now I'm going to try and just, if I click this button on the screen, it will take some readings, and as you can see right now it's all saying zeros, but if I put three fingers on the screen and press the button, you can see it's actually given me 3 touch points, 3 to XY coordinates, XY coordinates, and XY coordinates. Now if I put them drastically apart and click the button and take another reading, now this time you can see there's only 2 coordinates because I've only got 2 fingers touching the screen here. And one of them is at 72,311. It's a 480 by 800 by 480 screen. So you can see one of them was near the bottom left, which is this 72,311, so it was about here. and the other one was way up here, which was 644, so it was close to the 800, but only about 100 scan lines down. If I put just one finger right in the middle and click the button, you can see it's roughly reading, well, 370 by 288. If I just change it up a little bit, you'll see 380, 206. If I go right to the top, that second reading is now only 19, but the 396, I'm still saying roughly in the middle. If I go right to the top left corner and do the same thing, they're both low values, and on the bottom right corner, you'll see they'll both be maxed out when it takes a reading. And I just generated some kind of exception over there. So in the forums, it does say that sometimes it will work, but after so many events occurring, it can sometimes cause an issue with the touch on the through the Pi interface, and that might have been what I just seen there. Okay, so basic touch functionality with the LCD display as provided by Microsoft doesn't work directly for the screen. As you saw, there are some rudimentary capabilities that you can program into your application, and probably with the correct error handling may well work reasonably well. As I say, the test program that I have right here is just a rudimentary one, so it's not meant as a full-fledged application. It was just an experiment to see if I could actually talk to the touch controller and retrieve data from it, and I can. I will go into more programming with the Lightning and GPIO with Windows 10 with this build in future videos, but that's not part of this one. I just want to keep this one short and sweet and basically just focus on how well the LCD display works for Windows 10 IoT. Now, if you're using a separate keyboard or mouse with this on the display, then obviously there is absolutely no issues right now because it does fully function. And only if you want to be using the touchscreen that you may have to program it, assuming it's not going to give us any issues. So if I just try this a few times, there's the touch 1, touch 2, touch. See if this, I can make it break. I'm just going to do a whole bunch of touch events. Okay, there's 4 touches there, 5 touches. Yeah, I think it's killed again. So there's definitely still a bug with the touch using the I2C through the side. The actual real I2C, there's 2 I2C buses on the Raspberry Pi, I2C bus 0 and 1, and I think 1 is the one that I've connected it to, but I2C 0 is still technically connected, and it may be sending data out over the other bus to it, and there's being a few conflicts. Yeah, this is crashed in the same place for the sensor read routine. So it may be my code because it's, as I say, I haven't made it robust. It was just a rudimentary test. You can see that you can talk to the touch controller and that it probably, once Microsoft gets to it, won't take them much to get it integrated properly. But for them, it's writing low-level drivers and testing and everything else. So, I can't say when it's going to be available, but hopefully not too long. It's a quite significant piece that's missing out of this and would make a lot of people very, very happy. Anyway, that's really all there is to it. As you can see, there is actually nothing that you have to do to get this working on the LCD display aside from plugging everything in, making sure you've got the latest build of the Windows 10 IoT, powering it up, and waiting for it to configure itself. You can then go in and tweak things, and all of the apps are going to work on this screen with the exception that touch capability is not really available yet. I would say that it's kind of there, but I wouldn't trust it right now without further testing to see if it's my program or whether it is just a core fault with the drivers right now, because there's that conflict with the 2 I2C buses. I will do more investigation, and once I have something more concrete to say about touch, I will do another video and include it. For now, that's it. So if you want a 7-inch LCD display to work for the Pi and you want it to work seamlessly through the LCD connector, then this does do the job. You just can't use everything that comes with this screen. But at $70, $80 for this screen, it actually is a very good value for money, even without the touch, and knowing that it will eventually be there. I'm certainly happy to use this screen with, say, a mouse and keyboard or something temporarily, or even just as a status screen for some remote application to display data, and knowing that, in the future the touch will be available. Now, under Linux, of course, under Raspbian, it's fully functional and there's not an issue there, so Node-RED and things like that can be used. I actually want to be able to use this under Windows 10 IoT and have full touch, so I'm going to have to be more patient and wait for that to come out. But anyway, that's it. That's the status for now as of January 2016. You've got the display working, but you don't have the touch capability working. And there's absolutely nothing you have to do to make the display work. You just have to plug it in as per the instructions that I've already shown you. Anyway, that's it. So I will see you on the next video. If you like this, give it a thumbs up. If you don't, well, then you don't have to. But we'll see you soon.